Have you ever wondered how to get from all this stuff to this? Hello guys, Michele here. Nice to see you back on the Moddog channel. It's been a while since the last video was uploaded, but we're finally back. This is me in the shop looking for the right piece of wood from my dusty stash. And that's because today we'll go through the creating process of our latest mod called Etheria. I'll be showing you every step from start to finish, from machining to assembly, so get comfy, grab something to drink and welcome back. This is the Etheria making of. When designing a new mod, I always start sketching ideas on paper. Most of the ideas are quickly discarded, until something decent begins to take shape. The 3D modeling process takes up to a couple of weeks depending on the complexity of the mod. I usually put all the components together like the 510 connector, the tube, the board, and then I design the body and the other parts around the first assembly. If something is outsourced, like the 510 connectors or the battery tubes, technical drawings are prepared. Okay, this is done. Let's get back to the shop. I've got this beautiful piece of olive wood and I need to find the best spot for the Etheria. I'm avoiding cracks or poorly textured areas. Having to deal with nice woods is so exciting to me. I love the grain patterns, the color, the smell. Olive wood has an incredible smell, maybe one of my favorites. Some other woods don't smell so nice. In general, there are so many things to say about woods, also regarding the stabilization process, but this would require a video on its own. This old manual milling machine is one of the machines I got from my granddad, and it's still used a lot in the shop. I often use it for squaring wood blocks like this one, or for other simple machining tasks such as drilling, facing, and so on. The stock size for the Etheria is around 85 by 50 by 30 millimeters, but I don't care if it's slightly bigger than that. Sometimes I get the blocks already cut to the correct size, and that speeds up the process a little bit. However, most of the blocks still have to be cut down to size or a lot of material will go to waste. So far I haven't used one single piece of those wood scraps, and it's been years of piling. I guess soon I'll need a bigger shop. On this first picture, I'm running a few operations. The bottom facing, the external profiling, and the tube housing. All done with this giant hand mill. Then a few tool changes to machine the up and down button pocket. I have a nice story regarding the CNC. In 2015, we bought our first CNC router, but we knew nothing about machining. In fact, for the first 6 months, we couldn't really use it because it was acting weird. Sometimes it moved randomly, and we couldn't understand why. We were pretty desperate because we couldn't machine anything. After months of tries and despair, it turns out we were simply overspeeding, and the motors couldn't handle that speed losing step on the toolpath. Something actually easy to solve, if only we had just a tiny bit of knowledge in that field. Now that I'm more experienced, this story makes me smile. I really don't like glue and I wouldn't use it if it wasn't necessary. Since the 510 connector is held to the body with these threaded inserts, I'd rather be safe than sorry and make sure these parts won't ever come loose. Here the machining is getting interesting and more complicated. In order to work the Etheria body on the rotary axis, I had to come up with these two aluminum jigs that allow me to clamp the body precisely and firmly. I also had to come up with a method to make sure the body is perfectly level and not tilted in any direction. Back to the aluminum jigs, they make sense now, but coming up with a solid machining strategy wasn't easy at all. Personally, I'm lucky to be able to design and manufacture these mods all by myself, so from day one, when I was still at the drawing board, my mind was already thinking about the machining. I wanted this mod to have a nice freeform shape, and I wanted to use my rotary axis to machine it. I want it to be very clean on the outside with no visible screws or panels. The main problem with that idea is keeping the assembly and disassembly process simple enough, avoiding glue or other irreversible actions. I had this idea of fitting all the electronics from the tube side and leave the tube visible. And it was nice because it will hide everything behind the tube, but it was also risky for the body, which could be too fragile. I modeled the surface of the body to get thicker walls in the weakest areas, hoping that the body would strengthen enough to be machined out of wood as well. By that time, I had printed only a few protos, and I was still figuring out the possible machining strategy. From my experience in machining, you always have many ways to achieve the same result. In fact, I was having different options to get this body done. I liked the idea of machining the most of it on the rotary axis, so I wouldn't have to move it multiple times. More fixtures equals less precision. This cut was giving me a lot of troubles when from machining plastic I tried machining wood. Almost at the end of the cut, sometimes the wood splintered inward quite badly, depending on the wood fibers. Then I figured out that I could prevent the splinters by drilling some holes before profiling. And I must say it works way better now. These cuts are crucial for the mod assembly, and if the tube is firmly attached to the body, it's mostly thanks to these features. At this point, the machining may differ depending on the customer preferences. The mod could either use the DNA60 or the DNA60 color. For this one, I'll go for the most wanted version, DNA60 color with USB port and dual fire button. At this point, the body machining is mostly done and I can start finishing it. First, I remove the aluminum jigs, and then I carve out some more room for the wiring. Unfortunately, there's not an easy way to do this with the CNC, but I actually don't mind using my hands a little bit. Back in the old days, we had carved all of our mods and it was kind of fun. Each one was different and I could play a lot with shapes and curves, but it was also easier to ruin a mod by poking through the body while carving it. On top of that, when shaping by hand, you can ruin them all, and sometimes I wasn't satisfied with the final result. With Etheria, I wanted a unique design that people could easily recognize and connect to the Moddog brand. However, finding the perfect design for the Etheria was probably the biggest challenge I had to tackle. I'm a perfectionist and a very picky person, so I made several one-to-one paper models with different views from the front, the back, the sides, sketching up different shapes and comparing them to find the best one. I wanted the shape to be sexy, but not overcomplicated, curvy, but still lean, and of course, comfy to hold in hand. Once I was done with the main shape for the body, I took on the most difficult challenge for me, finding the best shape for the fire button. That's a key detail in the mod appearance and it could change the mod character a lot. The freeform design of the mod called for something organic with the curves around the button, not something flat or squared. I remember trying a lot of different shapes, but I couldn't find anything that I liked for quite some time. In the end, I got inspired by the mod itself. I thought the external silhouette could be projected and scaled down to the button size to recall the whole mod design in the button detail. After a few minor tweakings that worked really well. Luckily for the up and down button, it was much easier. First of all, it was invisible, and secondly, it was located on a flat surface and not on a complex shape. The only thing I had to decide was either making two separate buttons or a single one. I thought the single button was more elegant and clean, and the slot shape was quite easy to choose since it's easier and quicker to machine. These are the silver tabs I use for the wiring. I don't think using silver for the solder tabs really makes any difference in conductivity, but it's easy to solder and it's nice to deal with. These cables are cut to a precise length for the button wiring. I find this solid core wire simple to handle when soldering on small pads. It's just a preference of mine, and when I can, I rather using a solid core instead of a stranded one. This is probably the task in the area assembly I enjoy the most. Overall, I like the wiring process more than machining one for several reasons. The shop is quieter, with no loud machines running all the time. I'm not watching the machine do the work, but I am involved in the process. It's relaxing, and I even find some tasks to be quite ASMR. Here again, I choose a rigid copper wire over a stranded one. Rigidity is not an issue when the wire doesn't have to move or bend around, with the big plus of an higher conductivity, especially on this power wire, which is the longest one of the mod. Soldering is one of the latest skills I picked up. At first, I was insecure and I hated it, but then I started appreciating it more and more. There is always a lot to learn, and I like learning new stuff, like removing the flux residue between the solder pads, which is important to avoid some kind of short circuits. To ensure the best cleaning, I wipe the solders with isopropyl alcohol, and then I put on a layer of conformal coating to protect them. These button boards were developed for another project which never made it to the market, called Hyperion. They are now available for other modders, but I figured I could also use them in the Etheria project. Another super useful thing we originally developed for the Hyperion that made it to the market as a product on its own, it's this amazing flexible cable to connect the USB charger to the DNA board. Easy to solder and use, it saves a lot of time compared to soldering 5 wires one by one. The DNA boards come with side rails which have been trimmed off already. Also, the onboard fire button has been removed to save a couple of millimeters in the mod width. All these close solders connect the buttons boards to the DNA. Removing the flux residue here is very important. I've had a board giving me issues and it turned out to be a flux residue problem in this area. Now I'm very careful to avoid this problem. This is the last wire soldered on the DNA board. To ensure a nice and strong connection, some solder is added on the back as well. Finally, these pads are pre-soldered for later. Easier to do it now with the DNA in the third hand. We can now start assembling the printed module. The charger is inserted first and blocked with a couple of M2 grab screws. Then it's time for the up and down buttons board. Handling these tiny wires is a bit tricky, but once they are bent in place, everything goes in perfectly, and the board can be screwed to the print. The same goes for the fire button boards. The power out wire is bent back into place. The flex cable is tucked in, and the wires are moved aside for the screen ribbon. Apparently these DNA 60 color screens are much easier to break compared to the old DNA 60 version. It happened to me a couple of times during the prototyping stage, but it never occurred again, so I think they are fine. Time to install the silver tabs. They are held in place with a screw and then soldered to the DNA board. The pre-soldering I did on the board is very important to ensure a good quality connection between the tab and the DNA. Another quick wipe and this is the final result. Those little legs holding the DNA board down are one of the reasons to love 3D printing. Endless possibilities and no extra cost compared to machining. At this point, I usually check if everything is working fine, and if it's all good, I apply the conformal coating, also protecting the fire button solder pads. Once the DNA is done and assembled in the printed module, it's time to complete the wiring of the 510 and the battery tube. A rigid copper wire is used for the 510 ground, and of course it's well insulated with a neat shrinking sleeve. The positive wire instead has to be flexible to move up and down with the center pin of the 510 connector, so a stranded wire was the best choice. Before the wiring, the 510 top plate is removed, then clamped with a piece of silicone to prevent any scratch. The positive wire can be soldered directly on the pin, because the silicone insulator can withstand high temperatures with no problem. The ground wire is fixed to the 510 body with an M3 grab screw. Let's prepare the cables for the tube. In this case, the positive and the ground wire are both stranded wire. I use the heat shrinking sleeves to differentiate them, the black one for the ground and the red one for the positive. Then the battery tube is taken apart and the sleeve engraved with the Eteria graphic. Soldering the ground takes some time, since the brass top plate has a big thermal mass to heat, while the positive is much quicker. Finally, the tube is reassembled and checked for imperfections. Okay, now it's time to put everything together. The 510 is screwed on the body with two stainless steel M2 Torx screws. The 510 connector itself is leak-proof, but the liquid can soak up in the wood and it may drain around the top plate down on the electronics. So I rather seal everything with this liquid silicone, which is easily removable in case of repair. Once the 510 is set, I insert the buttons. I need a piece of tape to hold the first steel, while I place the other fire button. Another great moment is removing the protective film from the screen. Then a gentle push to insert the DNA module in the mod, with the printed features clicking in their cuts. A quick check of the buttons and I can secure the module with a couple of M2 grab screws. These screws thread into the wood and the print, making the tube connection even more robust. The 510 positive wire is also tightened to the silver tab. Now, this was tricky to film. I had to keep the mod with an angle for you to see. But then it was harder for me to operate and get the screw started. Anyway, after a few tries, I managed to get it done. Another operation easier to do by hand is beveling this hole for the screw head. This screw will provide a solid connection with the mod, and it can be easily taken apart for repair. I've seen mods with glued tubes, but that seems like a nightmare to me. This takes a while, but at least it's a clean solution. The top plate O-ring is greased for a smoother adjusting and screwed back on the 510 connector. The Eteria packaging is SLA printed, with press-fit neodymium magnets. On the internal side, there are the Eteria graphic indicating the correct direction to insert the mod. Finally, the board firmware is updated with the latest service pack and our custom theme developed by a dear friend, Brandon Bear Keller on Facebook. If you made it this far, congrats and thanks for watching. Let me know in the comments what do you think and what can be improved. Don't forget to subscribe and follow us on Facebook and Instagram for more insights and daily updates. I'll see you guys the next time. Ciao!